Hi everybody, this is Mrs. Lehman from Math with Mrs. Lehman. I'm here with my 6th period class today, and we're going to do Module 5, Lesson 5. And the first thing we're going to do is actually take a look at page 12 in your modules, which was your homework yesterday. So we're going to quickly review the things that you learned so far in this module. So the first thing that you need to know, the first lesson we did was how to find the height of a parallelogram or a triangle, really. So you need to know that the height is perpendicular to the base. So again, when you get your height measured, you're standing straight up, you're not leaning sideways or doing anything weird, and you're forming a nice 90-degree angle with the ground, right? So we're looking for those same aspects when it comes to the height of a shape or a polygon. So in this first example, we know that the height is 4.4, and really a lot of kids will get trapped and they'll say, oh, it's 5.5. You're looking for this box that you see there to indicate that's a 90-degree angle or that they form perpendicular lines. The next thing we learned is the area formula for a parallelogram. So parallelograms could be squares, they could be rectangles, or they could be just a generic parallelogram. Pardon this terrible drawing you see here on the left. So that's a parallelogram-ish thing, and that means that it has two sets of parallel sides. So opposite sides are parallel. So whenever you have one of those, you need to make sure you're finding the height. So with a square and rectangle, it is the side length, but when you're dealing with a parallelogram, it's not the side. If it's a slanted, parallelogram, it's not the side length because that's not forming a 90-degree angle. Then we applied the formula base times height for all of those. We next learned areas of right triangles and areas of triangles, and again we're looking for the right angle and the base, and we just have to make sure we're including all of the base and that we're not including parts that aren't actually part of the triangle. So at number 1, to calculate this, you do area equals base times height divided by 2. You have your height of 4.4, and to find the entire base here, you'd have to add 3.3 and 6.1, which gives you a total of 9.4. Right? So then you would multiply those two numbers, divide it by 2, and that would give you your area. Number 2, same concept. We had to add 8 plus 16. You have 24 meters squared, and then for that base, and this one's kind of like standing on its head, it's okay, and that height is 14. So you'd multiply 24 times 14, divide that by 2. That's going to give you how many square meters it would take to cover that shape. Any questions on how to approach those two? All right, so really I wanted to save most of our time to go over questions 3 and 4. So there's a lot of gobbledygook here. It looks messy, but none of this math is complicated. It's just lots of baby steps, okay? So the hard work in this doesn't come from the calculations, really. It comes from paying attention and being a problem solver. So in this case, we have a trapezoid, all right? So this trapezoid has two bases, and it has, it's isosceles. It has two sides that are the same length, 13, right? And the one base is 12. The other base is a total of 22 feet. So there is a formula for area of a trapezoid, but we don't learn that in 6th grade. So we teach you other methods to find this. So one method that we are going to talk about today is when you break it into smaller parts, called decomposition. So we're going to break this into 2 triangles and a rectangle. So the first thing you needed to do is find the area of those triangles. So you can see here, triangle 1, right there, is with the dimensions of 5 and 12. So 5 times 12 is 60. You divide that by 2, you're going to get 30 square feet. Same thing for the other triangle. You have 2 exact triangles, so you don't need to redo the same exact math twice. It's the same dimension. So the other triangle, triangle 2, is also 30 square feet. The middle section is a square. We have a 12-foot by 12-foot section. When you multiply that, area equals base times height for any parallelogram. For a square, though, it's the same number, so it's really side squared, and that will give you 144. So that would give us a total of 204 square feet when we add all of those 3 sections together. So I know Lonnie, for example, said, I've got 3 different answers. You got to make sure you find the area of each piece and then combine them all through addition. Question? Okay, so we would have to look at each of these calculations. Did you plug in the right number. So the first one, you plugged in 12 times 12 divided by 2, and it should have been that, 72. All right, you divided it by 2 twice. Well, you don't want to divide that by 2. That's your parallelogram. So there's no dividing by 2 there. It should have been 144. Okay. On this next one, question 4, you could see this a few different ways. You could have seen 4 little triangles, right? But I think honestly it's easier for myself to look at these side things as, you know, a triangle right here and then another triangle right here. So the height of those are both 7, and the distance is not just here, it's all the way from top to bottom, so that's 48 times 7. That give you 336. Divide that by 2, you get 168 kilometers squared for this triangle right here. And again, they made life really easy by giving you the same dimension, so you just double that to get the area of both of those, so 168 plus 168. And then you also have to add the middle section, which would be 35 by 48. And the work for that one is up here for shape 1. All right, so you add those 3 sections together, and you're going to get 2016 square kilometers. Any questions on how to solve those? We're going to practice today, all right? So let's move forward to the next lesson, which is lesson 5, the area of polygons through composition and decomposition. All right, so you guys know that I have some, I'll say, different ways of describing some things, right? So on those last 2 examples, we looked at shapes that we broke into smaller shapes and then we added them all together, right? We added their areas together. We call that composition. And I compare that to building a snowman, right? No, this isn't Frozen or anything like that. Do you want to build a snowman? But what we're going to do is take it piece by piece and add them all together. The other way we'll talk about is something different, but I'll save that for the end. All right, so this is composition. What we're going to do is, first of all, we've got to make sure when we're finding the area of something, we have all the dimensions we need. And if you look in the magical math book of formulas, you'll notice that there is no formula for this weird shape, right? There's nothing in there that's going to tell you the area of this shape. So we have to essentially break it into pieces that we know, okay? But before we do that, we need the side length. So AB is 10 units, so we're going to label AB 10. FE is 8. It says it right here, okay?
Oh.
Yep, and then AF is 6, and DE is 7. So one thing that we know about rectangles is that opposite sides have the same length, right? So if we know that, we could look at this and pretend that's one big rectangle, right? And we know this whole side is 10, right? So we know this whole side is 10. Opposite sides are the same. And we know this side down here, opposite of this FE side, is 8. So what's our missing piece, DC? Lorelei? Very good, because 2 plus 8 would give us that total distance of 10. Does everyone see where we got that number? Okay, so again, Maddie, we see that this whole thing is 10, right? And we know 8 was given to us. So we're looking for essentially this missing section. So we had to figure out what number plus 8 equals 10. We just did a whole thing on algebra. So algebraically it would be what number plus 8 would give us 10. Okay, good. All right, if you have questions along the way, please don't hesitate to stop me, because I'd rather you ask me before you get, out on your own and have no clue what you're doing. So don't hesitate to stop me. And I can always pause the video if you're not comfortable asking on the video. But honestly, if you have this question, viewers are going to have this question too. Okay? All right, so we know that is a DC is 2. We've got to find BC. So I'm going to highlight that in red. All right, so again, we know opposite sides are equal. So if this is 6, over to here would be 6, right? What is this distance here? 7, right? So the total distance of BC would be what? Tucker? 13, he says. All right, so BC is 13 units. Write that down here. DC is 2 units. All right, we're going to kind of pick up the pace a little bit. That is how you find missing sides. You've got to use what you know to figure out the missing pieces. Yes? Okay, I'm going to pause the video for a second. Okay, we're going to move on to the next section here, which is this stage. So as you can see, some of the sides are labeled and some are missing the dimensions. So we're going to figure out what the missing dimensions are. So let's take a look at this. If we know this side is 7 across the bottom, and this amount is 2, right? You see that? That would be 2. This side would also be 2. What would our missing number for this little segment be? So 2 plus 2 is 4, right? 4 from 7. 7 minus 4 is 3. Very good. So our missing unit here is 3 meters, our missing measurement. All right, and we know this whole thing is 9 meters. Right to here is 4 meters. So what would this section have to be? Somebody said it. Liliana, 5. Very good, because 4 plus 5 gives us a total distance of 9. All right, did you have a question, Evan?
Miss Lehman, I'm cold.
You're cold? Okay, you can go stand in the corner because it's 90 degrees there. Ha 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 ha. Oh, feel free to steal that joke. It's, you know, it's a classic. He's not really cold. We may have staged that. All right, so we're going to move. Oh, well, if they probably stopped watching by now, let's be honest. All right. All right, I'm going to save you a lot of gobbledygook here for time's sake. I've done this lesson more times than I want to admit. So we're going to go down here to the bottom. We're going to try to find the area of this weirdo shape by chopping it into pieces and then adding the area of those pieces together. So
Why is it blue?
why is what blue?
Shape.
Because I have color on the screen. You don't have color in the print because that would cost big bucks, you know, print blue lines instead of black lines. All right, moving on. So they want us to draw 2 horizontal lines to chop this up. So this is what we're going to do. We're going to put a line here, and we're going to make this one of our rectangles right here in red. You're going to have to do it in pencil. All right, this is going to be in green for me, and then this one right here. So I'm going to have to speed this up a little bit. Okay, so we have 3 rectangles. Now that we've discovered all the different dimensions, we can plug those in and solve for each of these rectangles. So this is rectangle 1, we'll call this rectangle 2, and this will be rectangle 3. So for rectangle 1, we start with the formula, area equals base times height, right? That's a parallelogram, length times width for a rectangle. Area equals 2 is our base. What's our height? 4, very good. So 2 times 4 equals, not everyone at once, 8 meters squared. So we're going to write in here 8 meters squared. Now number 2 is going to be the same thing, right? Because we also have another 2 by 4 rectangle. 2 times 4, bless you, is 8 meters squared. Does everyone see that it's just the same dimension? So we just can write that down. Now this one is where it kind of gets a little bit tricky. It's not even difficult, but just a little bit tricky. For rectangle 3, area equals base times height. A lot of kids will go, oh, it's 9, because they see this 9 on the side, but they, bless you, we had to, oh, there's like allergy season going on or something. All right, so we have 7. We have 7 as the base. We know that this section is 4, right, up top here in green. So what is this side going to be if it has to add up to be 9? Maddie? 4 plus what gives us 9? 5, very good. So our missing side is 5. So area equals 7 times 5. Well, what is 7 times 5? 35, very good. This class all of a sudden gets shy. Weird. All right, so now when we figure it out this way, we have to add those 3 pieces together. Oh, smart notebook can perform faster. Learn How? Well, we need to learn to perform faster too. All right, so we have 8 plus 8 plus 35. So 8 plus 8 is what?
16.
16. This is where the smart board glitches out. All right, so 35 plus 16. 5 plus 6 is 11. Carry your 1. 1 plus 3 is 4. 4 plus 1 is 5. So 51 meters squared is the area of that weird shape. Now, that's how my brain sees it. I see it, you know, chopping off those two top rectangles. Some people are going to see it differently. Some people are going to see two really long rectangles. All right? And everyone sees things a little differently, and that's fine. All right? So, we're going to save a few steps here. 2 times 9 is what? 18. So we know that the area of this one is 18 meters squared. Does everyone see where I got that number? The base is 2, the height is 9. Same thing for this guy over here, 18 meters squared. Now this section here is not 7, right? We've got to figure out what that section was. So we know this is 2 going from here to here. This is 2 from here to here, so that if the whole thing is 7, we know our missing piece is what again? 3. So this is 3 meters, and we said that this side was how big? We already figured it out over here. 5, yep. So we have 3 by 5. What's 3 by 5? 15 meters squared. Very good. So we're going to add those 3 numbers together. So 18 plus 18 gives you, very good, 36 plus 15. 6 plus 5 is 11. Very good. We're going to get 51 again. So 51 meters squared. And notice, we cut it up differently, but if you did it correctly, it should still add up to the same area. Let's take a look at this last one. There are people who are going to see this. They're going to see part of it done one way. They're going to go, oh, well, look at this. I got this rectangle right here. And then they're going to go, we've got that too. All right, so they've got 3 different rectangles. So we've already done the math on this. We know that little rectangle up here is 8 meters squared. We've already done the math on this green rectangle. That's 18 meters squared. Now this one we haven't done here in blue. Excuse me. So again, we don't want to use 7 because 7 is the entire distance, right? We want just this section right here. And what would that be if this amounts to and the total thing is 7? 5. So this is 5 meters. This we already found the length of. That's also 5 meters. That's a square. Doesn't look like that on my screen, but it looks more like that in the book. So 5 times 5 is 25 meters squared. All right, so we're going to go ahead and add those up. 8 plus 18 gives you up 26. Don't forget to carry that 1. All right, 25 plus 26, 51 meters squared. Well, that is a mess down there, but anyway, it says 51. Let's move on. Okay, so that is like I call building a snowman. You take it piece by piece, add it all together. Now, you guys are familiar with ice carvings or wood carving, right?
Yeah, those are
You start with a solid block of something and you whittle away or chip away the pieces that you don't need. So we can apply that same principle to this. We know that this side was 7 meters. We know this side was 9 meters. And I don't want you to scribble on your paper, but what we're going to do is find the area of this entire block here, this entire rectangle, and then we're going to carve out, we're going to subtract out the part we don't need. Okay? So that's another method. So what are the dimensions of the large rectangle? So the large is 7 by 9, right? And the small, going from what we already have done, that was 3, this was 4, right? The small was 3 by 4. What are the areas of the 2 rectangles? So we just need to do the multiplication. So the large, what is 7 times 9? 63 meters squared, good. And the small, 3 times 4 is what? 12 meters squared, very good. Now what what do we need to do? Instead of adding them together, we're going to take out what we don't need. So what operation is that mathematically? Subtraction. Good. So we're going to subtract. So we're going to use subtraction. And then we're just going to subtract those two. So I think that's actually the easiest way, don't you guys? In this case, what is the difference in the area of the two triangles? So 63 minus 12 equals 51 meters squared. Notice they are all what?
51 meters squared.
So we could say they're all equal because it's the same shape and the same dimensions. They should all be equal. All right, we're going to move on to the homework so that I can quickly show you what you need to do for the homework, because probably people are watching this because they're in need of assistance right now. So we are going to go to page 20, which is your homework. All right, it says determine the area of the isosceles triangle below, or I'm sorry, trapezoid below. The image is not drawn to scale, obviously. We are going to look at this. Now this should be a dotted line because these are not actually dimensions of that trapezoid. So you have two options. You can decompose it or compose it. Right? So you can either do the area of the whole thing and subtract out the two side triangles, or here's something you haven't really learned yet. So here's our trapezoid, right? If you go from one vertex to the opposite corner, right, just like that, you've now turned it into two what? Triangles. So let's say this red triangle would have a base of what? What's the base length of that? 3, right? That length right there is 3. What's the height of this triangle? 12. So 3 times 12 divided by 2, right? Just show your work. You can use a calculator as long as you write down your process. Now, you'd have to find the area of that, then find the area of this one. What's the what's the base length of this triangle? What? I can't hear you guys. 18. It's just kind of upside down, right? So that's the base. What's the height? 12. So 12 times 18 divided by 2. Add those two dimensions together. The other option would be to encase it all, which I honestly don't think is as easy as the two triangle method. But that's just me. Some people, we'll talk about that in a sec. Okay, so the other way is to find the area of that rectangle, 3 by 12, and then subtract out this and this. Now the only tricky part about that is this is 3. We know this entire thing is 18, right? So these are unknowns, right? So we've got to take 18 minus 3 would give us 15 unaccounted for meters, right? So divide that by 2 because it's in 2 sections. What would each section be? What's 15 divided by 2?
5.
7.5. Yep, that took a while to load. 7.5. Okay, so each section would be 7.5. That's going to be a little bit more work, in my opinion, to find the area of that triangle, this triangle, and then subtract it from the rectangle. Honestly, I think your best bet is to do those two triangles on the inside. All right, this next question makes me think that someone's painting their house wall with nail polish. It says the windows and door will not be painted. Calculate the area of the wall that will be painted. So obviously, you're not going to paint these, right? Don't do that. So you need to find the area of the whole rectangle, length times width, and then subtract out these 3 sections. All right, now let's read the next part. It says, if a quart of extra thick gooey sparkle paint, that's what makes me think of nail polish, because that's gooey, sparkly stuff usually. Gross, this wall would look disgusting. It covers 30 feet squared. All right, you got to figure out the amount that you need to cover, and then think about how many gallons would that, quarts, how many quarts would that take to cover that area. So for example, let's say I had 100 square foot wall, right? And it took, for one thing of paint, it covered 25. How many would I need? 4, right? You'd take 100, divide it by 25, you'd get 4, right? So same thing with this. You're going to find the area and divide it by 30. And you can't go to Lowe's or Home Depot and buy like a little tiny portion of a can. They don't let you like pour a little out. So you're going to have to round that number up to the nearest whole quart, okay? Any questions on what your job is? All right, sorry for the rush, Jen. Thanks for watching Math with Mrs. Lehman. Have a great day.
Please like and subscribe.
Thanks, Maddie. Bye.